Some people say if you have a 200 amp hour battery, you need a 200 amp fuse. But that's completely wrong. In this video, I'm going to show you the right way to size your battery fuse. I will show you which fuse types are safe to use on 12, 24 and 48 volt batteries using my custom chart. I also give you my recommended fuse sizes for your inverter at different voltages. If you're new here, I'm Nick, author of Off-Grid Solar Power Simplified with over 2500 reviews at 4.5 stars. Ready? Let's get started. The fuse does not protect your battery. The fuse protects your cable. The fuse needs to blow before the cable turns red and starts a fire. So you do not size the fuse based on battery capacity. You size the fuse by how much current your inverter draws from the battery. So here's how you pick the right fuse. I'll walk you through the steps. And if it feels a little overwhelming, don't worry. I will explain everything with an example later. The first step is to find the biggest current charging or discharging the battery. This can be your inverter, or it can also be a combination of a high current charger and the charge controller. We only care about the highest number. Most of the time, this is the inverter. The second step is to take the inverter power and then divide by the inverter efficiency. If you don't know the exact number, use 0.9. That gives you the real DC power being pulled out of the battery. The third step is to divide that by your battery voltage. Now you have the battery current in amps. Then we multiply the current by 1.25 for safety. And the last step is to pick the closest fuse size up from that number. These are the basic steps, but we're not done yet. At the end, we also check two things on the fuse: the voltage rating and the short circuit current rating, and I'll explain those in a minute. Let me show you this with a practical example, because now it will start to make sense. Let's say you have the following system: a 12 volt lithium iron phosphate battery containing 314 amp hours and a 2000 watt inverter. So what fuse should you put on the battery? Let's go through the steps I mentioned before. Our biggest load on the battery is the inverter. That's easy. The inverter has an output of 2000 watts. Then divide by the inverter efficiency of 90%. So 2000 watts divided by 0.9 equals 2222 watts at the DC input side. The next step is to divide by the battery voltage of 12 volts. And we get 185 amps. That means at full load, the inverter draws 185 amps from the battery. So the 200 amp BMS of this battery can handle the maximum current draw. I'm using 12 volts instead of the nominal 12.8 volts to account for voltage drop under load. Now we add the safety factor. 185 amps times 1.25 equals 231 amps. 231 amps is not a standard fuse size, so we round up to the next available fuse size, and that's 250 amps. That's your main fuse for the battery. Easy, right? Nowhere in that calculation did we look at amp hours of the battery. Not once. Amp hours does not decide the fuse size. To make it easy for you, I have created a table with different inverter power ratings at different voltages, so you can easily see which fuse you need without doing all the calculations yourself. you will have to round up to the nearest fuse size. As you can see from our example, we used a 2000 watt inverter at 12 volts. So we need at least a 231 amp fuse. So we choose the next fuse size at 250 amps. The size of the available fuse depends on what kind of fuse you choose, and I will talk about it next. I added a green and red zone in the image. I don't recommend going into the red zone, because that will be very expensive for your cables. So I recommend a maximum of 2000 watts at 12 volts. If you need a 3000 watt inverter, then I recommend choosing 24 or 48 volts. I made a video why a higher voltage makes your system cheaper, so you can watch it after this video. Okay, now that we know the fuse size you need, we have to pick the right type of fuse. We do this by checking the voltage rating and the short circuit current rating. First thing to check is the voltage rating. I have created a table that you can screenshot showing the different types of fuses that can be used for different scenarios. Every fuse has a maximum voltage. If you go past that voltage, that fuse might not actually disconnect the circuit. It can arc and keep conducting. So if your fuse says 32 volts max, that fuse is not allowed on a 48 volt system. These common automotive style fuses, MIDI, Mega and ANL, are only rated at 32 volts DC. That means they're okay for 12 volts and 24 volt systems, but they are not safe for a 48 volt battery. There is one exception for a 70 volt rated Mega fuse, but these are hard to find and expensive. MRBF fuses are rated at 58 volts, so these are great for 12, 24 and smaller 48 volt batteries. And then you have Class T fuses. These are usually rated at 125 volts DC, sometimes even higher in the case of NH00 fuses. Class T and NH00 is what I like to use on large 48 volt systems. So avoid using 32 volts rated fuses on a 48 volt system. That's how people burn their vans, garages or cabins. Don't do it. Now the second thing you have to check is a short circuit current rating, also called ICC. All that means is, if something shorts out and thousands of amps try to flow, can this fuse actually stop it? Or does it just turn into a welding rod and keep conducting? That rating matters a lot with lithium, because lithium can dump a ridiculous amount of current instantly. Let me show you how high that current can be. If I take a 12 volt lithium iron phosphate battery and measure the internal resistance at the terminals, it's 0.0066 ohms, and the maximum battery voltage is 14.6 volts. Short circuit current is voltage divided by resistance, so 14.6 volts divided by 0.0066 ohms equals 2200 amps. That's what you're asking the fuse or breaker to interrupt in that short. Now imagine 2, 3 or 4 batteries in parallel. You can get fault currents in the thousands of amps. That's why I also recommend fusing each battery in parallel. So if your fuse can't interrupt that current, it will just sit there arcing, and the wire will start to melt and cause a fire. And no, do not rely on your BMS to break a short circuit. That's marketing. As you can see in the table, I have added the maximum recommended battery size for each fuse. This is based on the datasheets of my recommend fuse brands. which I will tell you later in the video. So in our first example of the 12 volt 2000 watt inverter, we needed a 250 amp fuse, and the battery was 12 volts at 314 amp hours. So can we use a mega fuse? At first, you would think so, because the mega fuse is rated for 32 volts max. But the short circuit current interrupt rating is only 2000 amps at 32 volts. And as a rule of thumb, the possible short circuit is 10 times the battery capacity. So 314 amp hours times 10 equals 3140 amps. So a mega fuse is not suited. The fuse we should use is an MRBF, ANL, Class T or NH00 fuse, because these can interrupt the short circuit current while the mega fuse cannot. About a year ago, I made a video where I test a 40 amp mega fuse from Bojack, and it did not blow at double the rating for 2 minutes. That's not protection, that's decoration. So here are the brands I recommend, not in order: Littlefuse, Blue Sea Systems, Bussmann, Fastronic, Off-Grid Tech, Eaton, Siemens, ABB, Mersen, Hager, Schneider and Legrand. So can you use a breaker instead of a fuse? Yes, but be careful. These little cheap automotive breakers, the ones with the red reset button, I don't trust them. Also, a lot of these have a very low interrupt rating. In a real short, they might weld shut instead of opening. That's useless. I have never and will never recommend using these. There are ones I do trust, like this one from Blue Sea Systems, but it says maximum 48 volts. But the lithium iron phosphate 48 volt battery charges to about 58 volts, and that is above the specification, so don't use this in a 48 volt system. Then you have proper DC rated breakers, called molded circuit breakers. You will see things like 500 volts DC at 600 amps and an interrupt rating of 25,000 amps, just like a Class T fuse. A few months ago I made a video about these, so check it out after this one. Just one note, I don't like using them as an on-off switch under full load, so turn off your load first and then open the breaker. Let's size the cable next. That's quite easy. First you pick the temperature rating of your conductor insulation. This can be 90 degrees Celsius for PVC, 105 degrees for synthetic rubber, also called welding cable, or 200 degrees Celsius for silicone insulation. The higher the temperature rating, the higher the current carrying capacity of the cable. So for a 250 amp fuse we chose earlier, we need to find a cable that can carry at least 250 amps. If we choose welding cable, then we need a 1 gauge or 50 mm square cable. If you were to choose a cable with 90 degrees Celsius insulation temperature, then you would need a 4/0 or 120 mm square cable. So it's important to know what temperature rating your conductor has. I generally recommend using welding cable or silicone cable. I found a good supplier on AliExpress for silicone cable, and I will link it in the description. Now what if you have multiple batteries in parallel? I recommend fusing each battery, so each battery has its own fuse coming off the positive. That way, if one battery or one cable shorts, it doesn't short the rest of the battery bank. I made a separate video on how to calculate fuses for batteries in parallel. I also made a video on how to fuse batteries in parallel with different capacity. So here's what we learned today. Size the fuse by the maximum current your inverter can draw. Make sure the fuse or breaker is rated for your system voltage and can interrupt the fault current. Then size the cable larger than the fuse. If you learned something new, please click the like button and consider subscribing. You can watch this video next. Thank you for watching, and I will see you in the next one.